We're live. Well, we're being recorded. Okay. Oh, whoops. Hang on. We still have one more thing to deal with. You guys aren't looking at the right screen. Oh, and I think I just marked you away. What's your last name again? There you go. There we go. There we go. And changed. And okay, I can close this now, or just shrink it anyway. Okay, so let me open this. Oh, right there on, nope, further over, right beside the ball of elastics. That's it. It says trigonometry on it. Sorry about that. I missed your desk. Okay, so we need to get this up and running. There we go. Join. This is the part I might need a little bit of help with. Don't tell me. Is that 0385?
I can't tell him.
Yay. Thank you. Some days the eyes work better than others. There we go. Okay, now we're rolling. Okay, so things we need to know about triangles that are just sort of assumed background knowledge from junior high is the Pythagorean Theorem. And at the high school level, we kind of hope that you understand it both as a formula and as just an understanding of space. Most people kind of forget. They think it has to do with the sides, but it's really kind of about area, right? It's about if I took any right triangle and I turned this edge here into a square, and I turned this edge here into a square. This will barely fit, I think. And then this one, okay, that looks kind of like a rectangle. Let me erase that last line. I guess it would go more this way. And then if I made this side into a square, right? And that looks kind of rectangle. That one went too far the other way. But you get the idea. If I make 3 squares here, those 3 squares have an area that actually equals the 2 small ones equal the big one. So if that makes sense to you, let's do it as an actual formula, which is, again, the way that you were supposed to learn this back in junior high. First of all, in this triangle, most people have this memorized A, B, and C in that order. But you know what? Look at this triangle. This is actually side A down here because it's across from angle A. And this would be side C here because it's across from angle C. You always label sides with the same letter as an angle that it's across from. So B is right there, and that's, I always handwrite my lowercase b's, otherwise they start looking like 6s. So now, normally, the way I get people to remember Pythagoras is not with letters, but with words. You can use that too. You could say, I'll stick with the words you learned in junior high. Leg squared plus leg squared equals hypotenuse squared, because that is the other word for a line that isn't the hypotenuse. It's a leg. But I like those words too. I'm going to use those too. You could say that from a specific angle, like say for example from angle A, side A is an opposite side, and side C would be what we call an adjacent side. Thank you very much, Mr. C. But the hypotenuse is still just a hypotenuse, right? That's the word for the longest side. So in this case, it's not a squared plus b squared equals c squared. According to this triangle, it would be a squared plus c squared equals b squared. And I always stress this because you get students who come out of junior high, and if you give them a diagram where it's not labeled A, B, and C, they just can't do Pythagoras because that's all they know is it's got to be A and B on the left side and C on the right side. And certainly, you should not limit yourself to specific letters meaning such specific things. We can use variables for whatever we like and in any way we like. We don't even have to stick to English letters if we don't want to. So keep in mind that, okay, in this triangle, this is definitely going to be side C, this is going to be side A, and this is going to be side B. So in this triangle, leg squared plus leg squared equals hypotenuse squared. Now let's plug in our numbers. 8 squared, we'll actually do the long way, plus 12 squared equals c squared. 64 plus 144 equals c squared. And let's see, 60 plus 140 is 200, so 208. Now, is 208 a perfect square? No, it's not, because 196 is 14 squared and 225 is 15 squared, so it's 14 point something. This is where we get to use our calculators, and that's why I told you starting today we better have a calculator. So 208 square rooted, it even says 2 decimal places, which is a code that, oh yeah, I better get my calculator out for this. So I'm looking for a c value, so c squared is equal to 208. So the square root of c squared and the square root of 208 is the step that isolates c for me. I think of this as algebra, right? I'm undoing the squared so that I can isolate c. And 208 square rooted is 14 point, and the thing after the 2 is another 2, so 4, 2. And do we have units on this? No. If it doesn't have units, you can just leave it as a number. All right, this one you could probably do mentally. Let's try it. So in this case, again, let's make the formula first. What letters would we use? What would you call this side up top here that's the 4? I'd call it side little g. What would you call the side down here by the 6? Side lowercase e, and then the hypotenuse has to be f. So according to my formula, g squared plus e squared equals f squared. Does it matter if I put the g or the e first? No, because you're adding, you can add two things in any order you like, right? Now let's plug in the numbers. 4 squared plus 6 squared equals f squared. Okay, so that's definitely 16 plus 36 equals f squared. 16 and 36 is, how much is that? That's 52. So this one you could probably, well, it does say 2 decimal places. Certainly 1 decimal place you could handle. What's 52 between? Between 49 and 64, a little closer to the 49. So yeah, okay, so but we need a second decimal place. So f squared equals the square, oops, no, that's wrong. Don't write that. F squared is equal to 52, so f is equal to the square root of 52. And let's see, 52 square rooted, 7.2, but the next decimal is a 1. Nice job on getting the 2 there, estimators. Any questions on how we did that? There is one level tougher than this. What if we knew the hypotenuse and you were looking for a side? All right, so I still start with the formula the right way and then I move it around, but I like the way you're thinking. Okay, so this would be the b side that we're looking for. We know the a and we know the c. So again, according to this triangle, the formula is a squared plus b squared equals c squared. Again, never assume that that's the way the formula is going to look. Look at your triangle. And I know the 7 and I know the 11. I would minus the 7 squared from both sides. Again, I think of this as algebra. So b squared would equal 121 minus 49. So you can use your calculator for that if you want to. 121 minus 49. And so b squared is equal to 72. So square root both sides. And b is the square root of 72. And again, it wants 2 decimal places. This one has to be 8.49. Because the thing after, this was an 8 on my screen, but the thing after the 8's a 5. Okay? All right. Let's give you a try. You do B and C without my help. This, we are using the formula. There it is right there. Yeah. Yeah, you want to use leg, hypotenuse, go ahead. But at some point, you should get used to actually using letters. But don't just memorize that, hey, this formula always uses these letters. Use the letters appropriate to the diagram you're looking at. That's going to be really important as we go on later in the unit. Okay. Sure. But I do kind of want to see you use the letters that we're looking at here. Too bad, because the letters are going to be, and how we label things is going to be really important in a few minutes. You got to get used to the symbols. You'll see why. Oh, you could do that too, yeah. Yeah, you could. You don't have to call this side here little b. You could call it side AC. Yeah, you can do that too. So your formula would be AC squared plus BC squared equals AB squared. And that's fine. Okay. But you kind of have to still get used to doing it this way because this is the way we're going to do things in trig. Angles and sides share letters. Angles are the uppercase and sides are the lowercase. Okay, let me see if I can catch up to you. So I would use my lettering system. I would make that an X. I'd make this a Y. And I'd make this a Z. So my Pythagoras is going to be X squared plus Z squared equals Y squared. And I'm looking for Z this time. So 7 squared plus Z squared equals 17 squared. So Z squared, this one's a subtract. (289 minus 49, right? 240. Is 240 a perfect square? No. So that's going to be a decimal 15.49 if we'd use two places. And again, there's no unit on it, so you don't have to put centimeters or anything. And this one's actually got a decimal. I would call this little n, I'd call this little m, and I'd call this little l. And according to Pythagoras, L squared plus N squared equals M squared. Would it matter if you switch the L and the M, and the L and the N? No, not at all. So L squared is what I'm looking for. 15.2 squared is equal to 18.3 squared. And that's going to be a subtract. And I would do this all in one button punch. 18.3 squared. I don't really care what 18.3 squared is, so don't bother writing it down. Minus 15.2 squared equals 103.85 squared. Okay, I know it's going to be around 10. 10.19, the thing after the 9's a 0, so 10.19. Yeah, we don't know what unit is, so don't bother. Okay, any questions? I know we got that far. So that's where we should be coming out of grade 8. Then in grade 9, I think Pythagoras might pop up a couple times, but not a lot. So this might be something you haven't really thought much about since grade 8.
We also did this in grade 10 essentials, and we also got to tangents and stuff.
True. Those of you who have taken the other course in grade 10, you saw quite a bit of this. Yep. Okay, moving along. Example 3. This. What's that, sorry? Did I punch buttons wrong? Yeah. Uh-oh, let's see. 18.3 squared minus 15.2 squared equals square rooted. No, I stand by that. 10.19. The thing after the 9's a 0. Did I copy it wrong? 18.3 and 15.2. No? Yeah. No, you've punched buttons wrong. Don't worry about it. Squared minus 15.2 squared equals. Okay, I got to move along. All right. This is going to be one of the more important types of skills that we do in our trigonometry unit. We're going to have to know how to do some basic rational algebra, right? Think of this as a number is being divided by 5, and I have to figure out what that number is. So I'm actually going to multiply both sides of the equation by that number that I'm trying to get rid of, which in this case is a 5. But on this side, 5 divided by 5 is 1. I mean, that's why I did it in the first place. The goal was to eliminate that 5, and I did. So x is equal to 20. Now, because this particular step is exactly how this works every time, most of the time people don't bother writing that they multiplied it on both sides. Some people even think of it as I crossed and multiplied. This 20 crossed up and multiplied by the 1 to give me 20 times 1, which is 20. And by the same logic, this e is going to be, well, I times both sides of the equation by 3. On the left side, it cancels. So this is 3 times 5, which is 15. So that's fairly easy algebra for solving an unknown number on the top of a fraction or the top of a rational expression. But what if it's on the bottom? How do you divide? Is it 104 divided by 8, or is it 8 divided by 104? It's 104 divided by 8. Actually, it's still kind of algebra. What you can do is you can actually multiply both sides of the equation by x, and then divide both sides of the equation by 104. Or sorry, by 8, I mean. Duh. And that one actually goes in evenly, right? 13/8 is 104, I think. Okay. But again, these two steps here, come on, highlighter, come on, wake up. These two steps here work the same way every time. So it becomes kind of a very easy pattern to just realize, oh yeah, what's actually happening is the m and the 1 here are switching places, and the 15 crosses up and multiplies. So what's 70 and 35? 105? Somebody double check my mental math on that. And then this one is going to be a decimal, certainly. But again, what's happening is the y and the 5 are switching spots. Now, I'm not a big fan of not thinking algebraically. I like algebra. If we wanted a decimal for this, we could leave it as 8/5. 8/5 is a perfectly good answer. It's simplified. But that is, of course, 1 3/5, so 1.6. Now, as I was about to say before I got distracted by that decimal, I'm not a fan of not thinking algebraically. I think really, if you're working through this course, algebra is inevitable. This is not essential math, or you can kind of avoid algebra if it's not your bag. Even in applied math, they take quite a bit of the algebra you do in pre-calculus out of it, just so you focus on, here's our formula, here's how we use it to solve a problem. But in the pre-cal stream, if you're not fairly good at algebra, you're going to get burned pretty quick. So I like to think of just about everything I do algebraically, but I don't want to see people fail their trig test because their algebra skills need to catch up to where we are in trig. So I will give you this little hint. Some people would look at A, B, and C here, and they've memorized that, oh yeah, when I am looking for the number that's on the top, T for top, T for times. And when I'm looking for the number in the denominator, you gotta use a fancy word. D for denominator, D for divide. So if the algebra of moving things around is a little beyond you right now, T for top, T for times, D for denominator, D for divide will get you the right answer whenever you're faced with this kind of work. Now, where are we going to get faced with this kind of work when it comes to triangles? Okay, the booklet doesn't have this little example. So I just want to see if you know what to do here. Let's say I know that I have a building. And the building, come on building, I have a building. And the building, it's a sunny day. And the building casts a shadow on the ground that is, let's say, 250 meters long.
That's a tall building.
Well, that depends on the angle of the sun now, doesn't it? And let's say that I know that I am 1.8 meters tall, 180 centimeters, roughly. And I measure on the ground and find out that my shadow, this, again, I should have made that a dotted line. Let's make that a dotted line. Oop, ah! I was just trying to make that dotted, not wipe it out. Hang on. This is me. There we go. See, me. There we go. Thank you. Yeah, well, no, just the stick part's me. This is my shadow on the ground, and my shadow on the ground is going to be 2.5 meters tall. How tall is the building?
100 feet or 100 meters.
Now, what do I know about these two triangles? Oh, look at that. You went to the fancy word right away. I was going to use a word that is actually in some ways less fancy, even though it's a more complicated and longer to spell word. I was going to use the word proportional. And you've heard that word. Some people are nodding. Yeah, I remember the word proportional from math before. I remember the word proportional, I'll get to your question in a minute, from reading Spider-Man comics when I was little, right? Like, how strong is Spider-Man? And of course, Stan Lee writes in the 70s or the 60s, whenever, he has the proportional strength of a spider. Does that mean he's as strong as a spider? Because that's not particularly awesome. You know, you could stomp there. That's not much of a spider, right? Like, I don't care I don't care how venomous a spider is. I'm quite a bit stronger than any spider. So he's not as strong as a spider. In other words, he has the proportional strength. What does that mean? What does a 5-year-old make sense of that reading a comic book? So I'll get to your question in a minute. What does that mean? So basically,
he has the same strength that a spider would have if it was the size of him.
right. Oh, that was said beautifully. I don't know if the people at home could hear that. He has the same strength a spider would have if the spider was as big as Peter Parker. Spoiler, Peter Parker Spider-Man. So,
Oh my God!
if you took the spider and you multiplied it by a number to make it as big as Peter Parker, then you took its strength and multiplied it by that same number. There's your proportion. And that's what these two triangles are. Somebody already knows the word similar. What are you thinking?
The tower is 180 meters tall.
That is exactly true. The tower is 100, or the building or whatever, is 180 meters tall because these triangles are similar. How do I know they're similar? Well, because their angles have to be the same. Mr. Sun is going to shine at the same angle for both the building and me. So it's going to be the same angles here, the same right angle here. I only need to know 2 angles are the same in a right triangle because, oh, there's something else you know about all triangles. What happens if you add up their 3 angles?
180.
You get 180. So all I really need to know is 2 triangles have 2 angles the same, and I know they're similar. And similar doesn't mean the same size, the same way that Peter Parker is not as strong as a spider. It means they're proportional. It means there's some number I could times this triangle by and get this triangle. And in this case, it was 100. Right? That's a very important idea moving forward. That's actually kind of the basis for all trigonometry. It's that triangles that are the same shape will be proportional. And there'll be some number you can find that you times one of them by and you get exactly the same size as the other. Okay, good. So that's an important idea that for some reason they didn't put in the notes. But we've talked about it. It's all good. Okay, here we are with the official labeling notes. We name the sides of a triangle, right triangle, any triangle, in relation to one of its acute angles. So angle B is an acute angle. Acute just means, of course, do we know that that means just less than 90 degrees? That's what acute means. You should know that from elementary. And so label the following right triangles in relation to their given angle. So in relation to their given angle, in relation to this B, this side over here, which again I could call side B, is the opposite side. It is opposite to angle B. This side at the bottom here, side little a, because it's across from A, is called the adjacent side. It is the side next to the angle. And you might be thinking, well, there's 2 lines right next to the angle. Yeah, but this guy has its own special name already. It's the hypotenuse. So that is how we label triangles from now on. We use letters, I'm sorry if you don't like that, but we use letters that are always the same as the angles across from them, just the lowercase versions. Or you can, of course, call this side AC if you wanted to, but that's using 2 symbols when you could use 1. So there's a lack of efficiency there if you think about it. And we also make sure that we label or we name the sides according to this opposite adjacent hypotenuse scheme from now on. Now, you might be thinking, oh, why couldn't I call this height and base? Well, there's a reason why you can't use height and base. Well, you can, but height and base is limited to the orientation of the triangle. Like, what if I tip this triangle over? So it's still the same triangle, but now angle B is over here, right? Now this side that was a base is suddenly a height. But if this is side B, it's still opposite to this angle I've put this weird symbol in. The weird symbol, by the way, is a Greek letter called theta. And just like in math, just about any time you say, oh, I need a variable here, the default choice is almost always x. In geometry, the default choice for a variable for an angle is almost always the Greek letter theta. It's like a little circle with a line in it. Okay? So let's try it on your side now. Okay? Label these 2 triangles with, first of all, the lowercase letters for their sides, and then tell me which side is hypotenuse, opposite, and adjacent to my theta angle. So take a look at how I did the A one and see if you can do the B and the C one. I'll give you a minute. And, oh, Sheng-Jun just joined us, so okay, hang on. I gotta go back. Is this the question you're talking about? Do you want me to go back to that one? I also have the question in the chat, what is the upcoming test out of? I don't know. 30 something? I don't know. 40 something? Difference does it make? It could be out of 500. What difference does it make? Is that enough backwards? Can you see now? Are you good? Or did I have to go back further than that? Sorry, I kind of wasn't looking at the chat there for a minute. Oh, back to example 1. Oh my goodness. Back to example 1. Okay, I'll do this for really quickly to example 1 for my person in the chat here who must have joined us late. Okay, and meanwhile, everybody else in here should be, where's my trig notes? Oh, okay. Everybody else in here should be labeling triangles. Okay, can you take a screenshot of that so I can move on? Okay, not you. Person at home. Person at home who missed example 1. Okay, here we go. Back to B and C. Okay, whoops. So let's see. That's little b in this triangle. That's the ugliest b I've ever drawn. I'm going to try it again. That's little b in this triangle. That's little c. That's little a. Good? From this theta angle here, from this theta, c is the opposite side. It makes sense because angle c is opposite side c, for one thing. And another way to think about it, if you're struggling with this, another way to think about it is the opposite side is the one that the triangle opens up. For people watching this on video or at home right now, this is not very, oh, you can see me on the camera. I'm opening, right? The two lines that are adjacent and hypotenuse open, and how far they open determines how big the opposite side is. So opposite here, adjacent here, and B is the hypotenuse. Another nice trick for never messing this up is to think of the right angle symbol like it's a little arrow that always points at the hypotenuse. I'm sure your grade 8 or 9 teacher probably pointed that out to you at some point. All right, for the C one, side C is here, side A is here, side B is here. From this angle, C is an opposite. B is my adjacent. And side A in this case is the hypotenuse. So hopefully we have broken you of any bad junior high habits of always saying, I memorized a squared plus b squared equals c squared, and c had better always be the hypotenuse. Nope, don't do that. From now on, we label and look at our triangles based on the situation. We might use letters that represent points on a map. We might use letters that represent the first names of 3 cities on a map, for example. The letters are going to change depending on the situation. Okay, so that's, I think, as far as we'll go today. We'll pick this up here tomorrow, notes-wise. So, yeah, we'll leave the depression for tomorrow. It's such a nice day. Why get all depression? Okay, so we'll pick that up there tomorrow. So I'm going to stop the weird video.